Assalamualaikum and hi, we are from Group 4 and now we want to present our project. But first, let me introduce our members. The first is ALYA ATHIRAH binti Sarahanis, second Nur Fatin ATHIRAH binti Fauzi, third Nur IZZATI ALYA binti Muhammad NASRON, and Nur ZAIRITA ZULAIKHA binti Muhammad ZAILANI, and the last is me, Muhammad Faisal IRWAN bin MOKHTAR. First, introduction. Pipe network analysis is calculation of fluid flow and pressure drop in complex piping system. The analysis of piping system is critical for public utilities to customers for consistent delivery pressure and flow rates. Solving pipe system for distribution was particularly difficult due to the non-linear relationship between head loss and flow. The next is objective. First, to analyze the discharge Q needed in every pipe for the water supply. The second, to determine the head loss in each pipe by using HAZEN-WILLIAM equation. The third, to find the value of correction for each trial to be applied algebraically to the discharge of each member of the loop.
Assalamualaikum warahmatullahi wabarakatuh. My name is ATHIRAH binti SHAHARAZIZ. My metric number is PF200011. So now I will explain the result for our analysis. From the figure here, show the water supply system in town A that already given in the task. From the task, we were assigned to analyze the discharge in each pipe. So from discharge Q inlet and outlet that given for our group, we analyze the calculation is only involved at log 1 until log 4. So from the table here, we show the data that are already given in the task such as length, diameter, and friction force that we already convert into meter. For the K value, it's derived from formula K equal to 10.67 times length over HAZEN-WILLIAM coefficient power of 1.85 times diameter power of 4.87. We assume the value of HAZEN-WILLIAM coefficient of pipe that we use to find the K is 100 for cast iron cord 10 years old. Our analysis is start from log 4 because discharge Q inlet is at node J in log 4. So discharge Q inlet is 0.09 meter cube per second that already given. For try 1, we assume the value for Q to make it balance between the open and end of the pipe. So for Q1, in pipe 11 is 0.075, pipe 10 0.017, pipe 12 negative 0.015, and pipe 13 is negative 0.015. Each lobe is rotated clockwise to determine the positive or negative sign. So head loss HF is defined by formula HAZEN-WILLIAM. HF equal to K times Q power of 1.85. So next at column beside head loss, 1.85 times K times Q power of 0.85 is derived from equation head loss. Sign for this formula will be neglected and will just show positive value. After that, we calculate the total of head loss and derivation of head loss. So for TQ is find by using formula negative total head loss over total derivation of head loss. For try 2, Q2 is sum of Q1 and DQ. It keep repeating until correction DQ is 0.000xx. And we get anti-try for DQ is negative 2.6x times 10 power of negative c. So final discharge Q at pipe 11 is 0.0594 and pipe 10 is 0.00136 and pipe 12 is negative 0.0306 and pipe 13 is 0.0306.
Hi, Assalamualaikum. My name is IZZATI ALYA binti Muhammad NASRON. My metric number DF200032. Today, I will to explain how I calculate the loop 2. First, we go to the formula. For the first formula is how to get HF. If you can see in my slide, this is all of formula. Next, for 1.85 KQ power of 0.85 we use the second formula. For the Q2, we use the third formula. The all of calculate for DQ use the fourth formula. Next, we go through to the pipe. First, for the Q1 in pipe 6 is 0.05, pipe 5 is 0.05, same with the pipe 6. And then for the pipe 3 is 0.01, and for the pipe 7 is negative 0.008. Then for the Q2 is come from Q1 and it's be repeats until the correction total of DQ is for try 2 is a negative 0.0075. For the try 3 answer of calculate the DQ is negative 0.000197. So for the final pipe 6 is 0.018, pipe 5 is 0.018, and then for the pipe 3 is negative 0.022, and the last pipe 7 is negative 0.040. This is the calculate of loop 2. Next, I will continue with my presentation for the loop 3. If you can see in my slide, this is all of the calculates and then all of the formula we use in the loop 3. It same from the loop 2. First, for Q1 in pipe 7 is 0.008, pipe 4 is 0.018, pipe 8 is 0.028, pipe 10 is negative 0.017, and pipe 9 is negative 0.002. Then Q2 is come from Q1 and it's be repeats until the correction total of the DQ is for try 2 is 0.00066. For the try 3 answer of calculate the DQ is 5.2927 power of 06. For the final of Q in pipe 7 is 0.0144, pipe 4 is 0.0244, pipe 8 is 0.0344, pipe 10 is negative 0.0106, and the last of pipe 9 is 0.0044.
Assalamualaikum. My name is Fatin ATHIRAH binti PAUZI. I will continue my part of our presentation for loop 1. For loop 1, we try until 3 trial to get 0.000 for delta Q. For the first trial, delta Q that we get is negative 0.016 2415 meter cube per second. For second trial, we get negative 0.00535 meter cube per second. And the last one, which is third trial, we get 0.000157776 meter cube per second. And the table show the data we have calculated for loop 1. I'm going to talk about feature water system for the first trial, and we need to find the difference based on the flow rate. In this feature, the flow rate are 0.040 and 0.050. We can see water supply system for the last trial, and in this feature, we still using the flow rate, which is 0.0183 and 0.0185.
Hi, my name is ZAIRITA ZULAIKHA binti Muhammad ZAILANI and my number matrix is TF200037, and today I would like to continue the last part is conclusions. A piping system are normally considered to consist of them completely internet connections between one location to any other location, or a network of pipeline conveying water to customer, which is the additional recognized as the distribution system. A piping network have quite large range of realistic purpose, and it has design that can meet water requirement, the like commercial, domestic, and industrial. Next, the most popular method for solving the problem is using Hardy-Cross method. Hardy-Cross technique is an iterative method is for deciding the goal with the flow in pipe network structure. The Hardy-Cross method with HAZEN-WILLIAM equation can provide way to measure every junction and follow in pipe network and consider every loop internally, assuming that the condition remain unchanged in the work reminder. That's all from me. Thank you.